Hello everybody and welcome back to Advanced Maths. Today we're looking at the equation of a circle on a graph. So here we have a circle and it's got a centre of 0, 0 and it's got a radius of r. The equation of the circle is x squared plus y squared equals r squared. This is a typical form of any circle on a graph. We can also change the centre by making it x minus a squared plus y minus b squared equals r squared, where now the centre is a, b. The radius is still given by r, which is r squared in the equation. Just notice that x minus a is the opposite of the x coordinate. So you will make, if it was a positive x coordinate, it would be minus a. If it was a negative x coordinate, it would be positive a in the equation. Same with b in the y bracket as well. Here's an example. X plus 4 squared plus y minus 1 squared equals 36. Here the x coordinate of the centre is minus 4, the y coordinate is positive 1, and the radius is 6 because that's the square root of 36. Okay, I think we're ready to see an example style question. So, consider the equation x squared minus 4x plus y squared plus 2y minus 20 is equal to 0. Find the coordinate of the centre. Okay, so we're going to look at the equation of this circle, and the x squared minus 4x, we're going to combine that by completing the square. And it's going to become x minus 2 squared minus 2 squared. That is just completing the square. If you're not familiar with completing the square, please watch my video on completing the square before we continue. I will link that in the description below. Now the y squared plus 2y, you complete the square to get a y plus 1 squared minus 1 squared. And the minus 20 on the end stays the same. And it's still equal to 0. We can simplify this by squaring those numbers. And the minus 4, the minus 1 and the minus 20 combine to be minus 25. And we can move that minus 25 to the other side to make it positive 25. Now we have it in a typical circle equation form. And we can see that the coordinate of the centre is 2 minus 1. The radius will be the square root of 25, which is r, which is 5. And we have all the information we need about this circle. So the centre is at 2 minus 1. And the radius of this circle is given by 5. Part C now, it says show that the coordinate minus 2, 2 lies on the curve. Well, to do this, we're just going to substitute in x is minus 2, y equals 2 into this equation and see if it makes sense. So we substitute in those numbers and we get minus 4 squared plus 3 squared. And if you calculate this, you get that the left-hand side is 25 and that's equal to the right-hand side, which is also 25. And so this equation makes sense for x is minus 2, y equals 2. Therefore, that equation lies on the curve. Excellent. So here we have a sketch of the circle and the two coordinates we know. It's asking to find the equation of the tangent to the circle at minus 2, 2. Well, to do this, the first thing we're going to do is calculate the gradient of the tangent. The gradient of the radius. And we know that the radius will be perpendicular to the tangent. So once we know the gradient of the radius, we can make it perpendicular to find the gradient of the tangent and go from there. So we use the equation y2 minus y1 over x2 minus x1, put those numbers in, and we calculate this to get minus 3 over 4. The gradient of the tangent is minus 3 over 4, and therefore we can calculate the gradient of the tangent by doing the reciprocal gradient, minus 1 divided by that gradient. Just remember to find the perpendicular gradient is the minus 1 divided by the gradient to get the new gradient. We get the new gradient is 4/3, and so the gradient of the tangent is 4/3. The equation will be y equals 4/3 x plus c. We need to find the plus c. To do that, we'll substitute minus 2, 2, because this tangent goes through the coordinate minus 2, 2. Okay, so we substitute in those numbers, x is minus 2, y is 2. We simplify, we add the minus 8 thirds to the other side, and we get that c is 14 thirds. We can combine the c with the y equals 4 thirds x plus c, and we get y equals 4 thirds x plus 14 thirds. And that's the final answer we have done. Thank you for watching this video with Advanced Maths. It's now time for you to practice yourself. I've got some practice questions on the screen for you to try. I need to copy and complete the table on the left, and then there's an exam style question in the red on the right. The hint 1 and hint 2 will be important for this. You will know how to find a midpoint. If you don't know how to find a midpoint of a 2 points, I have a video on that and I will link that in the description below. And then you'll also need to calculate the distance between 2 points using Pythagoras theorem for part B. Okay. Pause the video and try this yourself. When you're ready, I'll reveal the answers in 3, 2, 1. Did you get it all correct? Let me know how well you did in the comments below. Thanks for watching this week's video from Advanced Maths. It's great to have you here. Remember to like and subscribe so you don't miss any future videos. We're covering GCSE, A-Level and IB Maths, so quick and simple explanations, and new videos will be coming soon. Check out advancedmaths.com for more revision resources. Thanks for watching and good luck in your exams.